Hello there, welcome to Outmouse Labs. My name is Penny and I am glad you're here. Today we are going to be looking at Pixel Falls. This is, just as a reminder, a developing game engine that's currently in its pre-alpha. If you'd like to join that pre-alpha, you can find it on Patreon. I'll have that linked below. And today I'm going to be going through the basics of an adventure game. We're going to keep expanding on this, and this does kind of grow from what we covered last time. All right, so just like before, we have our engine loaded up in the browser at preview.pixelfalls.co.uk, and you do have to log in with your Patreon account. And I have, you may, if you're coming back and seeing this from the last video, it has changed a bit in the interface. It's a little bit more intuitive. Tags have been moved to the game settings. It's a little bit easier to read. And we have the option to change it to 30 or 60 frames per second, which is very nice. I'm going to set it to 30. Just like before, we can add palettes. I'm using the Miyazaki 16. I'll also include that in the links below if you want to give it a whirl. I think it's a very pretty palette. And of course, it came from low spec. Okay, then under our sprite editor, we always kind of want to set our sprites up first. I've just drawn a number of things. I've drawn a person, so our little character. I've got a wall, water, fancy water, water with rocks, grass, fancy grass, grass with rocks. I've got floor and spikes and bridge tiles, and then I've got a lock and a key. Okay, so I just drew all of those. You can import sprite sheets using that you make in, say, Aspirate, or you can draw it here in the editor. The sprite editor here is pretty full-featured. I did go over it in an earlier video if you'd like to check it out. Once you've got your sprites made, you can create your level. Levels are by default 128 by 128 split into 8 by 8 squares. This level is fairly simple. We have some grass, we have rocks, we have a river, we have a building, and we have a key and a lock. Okay? You do want to be paying attention to which sprites these are. So for instance, walls are sprite 3, keys are sprite 23. So you can find that information here under the sprite editor if you need it. You'll notice that every sprite has flags, so you can use flags to set all kinds of important things. I'm not going to be using them in this video, but if you're interested in learning how to do, say, collision or collectibles using flags, let me know and we'll do that next time. Okay, so we have our sprites, we have our level. Next up, we are going to go to our code editor. Under main, the first thing we're going to do is go grab a library from Substack that I'm very fond of. You can find it here. It was created by Wukai or Wookie. I'm not sure how that's pronounced. And I retrieved it today, and it is licensed Creative Commons by attribution. What this little library does is it creates a function under the table library or table commands within Lua, and it adds one called contains. What contains does is it looks to see if a given table has a specific element or value in it. It's extremely useful. Honestly, I think it could be in the base of Lua, honestly. But I went and grabbed it, so now it is available. Then under that, we have our init, our update, and our draw. These are our three sort of base lifespan methods. Init runs once when the game starts. Update runs 30 or 60 times per second, as does draw. Update will fully finish before draw is called. So everything will be done in update, and then draw will be called over and over and over again. In this case, 30 times per second. So, and in it, we create our player. So we have lowercase p player is an instance of a spawned uppercase p player. The uppercase implies that it's a class, and we're going to look at that player class in a minute. Update, we aren't actually doing anything in the update of the main, and then we're clearing the screen to black, and then we're drawing our map at 0, 0, 0, and it's map 0. That's all we're doing. Player is where most everything is happening. Player is a node. A node is called a class in many other systems. It's called a node in Godot. Sometimes it's called a game object. I believe that's what they call it in GameMaker. But in any case, it is a sort of standalone blueprint of code that you can make instances of in your game. Our classes or our nodes have the same lifespan method. So we have init, we have update, and we have draw. Everything that an instance of your player, in this case, can do needs to be defined in the init. This is important. So I have an x and y value, which can be set by the, which you can set manually when you make an instance, or it'll just be set to 1 by default. I have a can move, which is a Boolean true, a move timer, which is set to 0, it's a number, or integer. Has key, Boolean false. Walls is a table with a bunch of numbers in it. Those numbers are the sprite number that you can find in the sprite editor. Self-interactables is another table, again, with sprite numbers, 22 and 23 in this case. Okay, next we make a bunch of functions for our player. So self.checkCollision is a function which has a reference to the player itself. We say if table contains, which table? Self.walls. What are we looking for? Get map tile is built into Pixel Falls, and it gets a map tile at a certain location. What is that location? Well, it's map 0, layer 0, self.x and self.y. So in this case, if you were to run it as soon as the engine started or the game started, it would be map 0, layer 0, 1, 1. Now, it's important to remember that get map tile and anything involving the map is done in map coordinates. Map coordinates are those sets of 8. So like 0, 0, well, let's say 1, 1 is the first tile. Versus global coordinates or pixel coordinates, which would be, let's say, 8, 8 would be the 8 pixels over, 8 pixels down. It would be that one little spot. So these are in map coordinates. That's part of the reason that since I'm doing a grid-based game, I went ahead and made it 1, 1. You'll see how we move on the grid in just a bit. So if it contains, so if the self.walls has this number in it, then it returns true. Otherwise, it returns false. That tells us if something is a wall. Self.checkInteraction is another function. And it has one parameter, which is map layer. So we can look at different layers. Once again, table contains self-interactables. If it has if that table has the integer or the tile number on the map layer that we are in, it returns that tile number. Otherwise, it returns -1. So what we can do with that is we can then say, okay, if it's this tile number, then do that. If it's that tile number, then do this. You'll see how that's going to be useful in just a bit. Next up, we have self.controls. This is another function that takes an instance of itself. And you saw this in an earlier video if you've been following this series. Old x and old y are set to self.x and self.y at the very beginning. If self.canMove, so if the canMove is true, then we can say move to the right, move to the left, move up, or move down. If we hit the right arrow key, we run self.move, which is another function. You're going to see that in just a bit. And we send it to the right. And we also give it our old x and y. This is true for all 4 directions. Now, notice that little colon there. If you're not super familiar with Lua, this can be kind of tricky. If you do self.move, for instance, you would be running the function without sending the instance of the player with it. So by using the colon, it's just shorthand for sending self.move parentheses self. It saves you a little bit of time, and once you get used to it, I think you'll really, really like it. But that's why we're using a colon instead of a dot. Okay, so what does self.move do? It's our next function. It takes in a direction, old x and old y, and we say if the direction is the r, then which is a string, then self.x equals self.x plus 1. If it's an L, self.x equals self.x minus 1, and so on. Now, do remember that we can do plus equal, minus equal, those sorts of shortcuts in this version of Lua. It's something that Chris built into Pixel Falls. Most versions of Lua do not have that, so I have elected to not use that shortcut so that this is compatible with other code engines or other text engines that I want to use. This is because I do use Visual Studio Code sometimes to check code or to format code. The other thing is right now there's no way for Pixel Falls to sort of eject the Lua file that I'm aware of. So if I want to reuse this code in another game, and I probably do, I need to save it as a Lua file in Visual Studio. I'm hoping that eventually you'll be able to grab those Lua files directly out of your project. But for now, you have to copy it over and save it separately. So that's why I'm doing it without the shortcuts. Okay, so we set our x and y based on our tilt-up-move function, and then we run it against our collision, and then we determine if we can move, and if we can move, we do. Okay, so the way we do that is if self.checkInteraction 1, so 1 is the map layer, equals 23, and we have the key, then change something. Change tile 23 to tile 0. Or if interaction on layer 0 equals 22, and we have the key, then change 22 to 19 on layer 0. Finally, if we collide, we set the self.x back to the old x and the self.y back to the old y, so we never actually move. So that's how that works. Finally, we go into our update. We create our movement speed. This is so that we can hold down the button. So we say self.move timer equals self.move timer plus 1. And we say if that move timer is greater than or equal to 8, then we set can move back to true. Noticing that we're returning can move to false every time we make a movement. This allows us to hold down the button and still move along our grid. Okay, then under controls, we just tell it to constantly check our self.controls to see if the player is moving. And then we draw our sprite, which is sprite 1, at self.x times a and self.y times a. And this is how the grid works. So when our map tiles are, say, 1, 1, then the location is going to be 8, 8. When our map tiles are 2, 1, then the location is going to be 16, 8. So we move on a grid. That means that our upper left corner of our image will always be exactly on the grid, which means we can make these collisions and checks all work. Otherwise, you have to do a much more complicated way of doing collision, which is AABB algorithm, which we covered in an earlier video. Okay, so that is our player. That is our main. So now we have sprites, we have a level, we have code. What does it look like? Looks like this right here. If we move, we can see that we cannot go through our rocks. We can see that we move at a constant rate when we hold down our arrow keys. We also can't go through water, but we can walk on our wood. This is all because it's checking the collisions before we draw the movement. If we go to our door, we cannot just go through our door, but if we grab the key disappears, and now we can walk through our door. So that is the beginning of an adventure game and the code to do it in Pixel Falls. We're going to continue to build on this as Pixel Falls develops and as we learn how to do new things. Hopefully we're going to include things like enemies and puzzles. We might create the ability to have our player attack. We might create dialogue. Let me know what you'd like to see in the comments, and we'll see about making that happen. All right, I hope you guys will give Pixel Falls a chance. We're going to keep growing this. Thank you to Chris for creating Pixel Falls, and for the folks over on the Discord for just being wonderful. If you do like this kind of content, please consider a like and subscribe, and I hope you have a great day and happy game making.